Hello, good morning students. Find dy by dx if y equals to 5 root x minus 7 log ex minus 7 log x. Differentiating y with respect to x, d by dx of x to the power 1 by 2, 7 d by dx of x log x to the base c minus 7 d by dx of log x to the base c. So d by dx of x to the power n is nx to the power n minus 1. So it will become 1 by 2 x to the power 1 by 2 minus 1, 5 by 2 x to the power minus 1 by 2, d by dx of log x to the base is 1 by x, and d by dx of log x to the base is 1 by x log e to the base a, that will become 11 by x log e to the base a. So that is our final answer. Now the next one is y is given to us cos inverse of sin x. This sin x can be replaced in the complementary form, that is cos 90 minus theta. As we know that cos 90 minus theta is sin theta, so cos inverse of cos theta by the inverse trigonometric function, it will become pi by 2 minus x. As cos inverse of cos theta is theta, now we will differentiate with respect to x. Differentiating with respect to x, dy by dx will be equals to dy by dx of pi by 2 minus d by dx of x. D by dx of constant is 0 and d by dx of x is 1. So 0 minus 1 minus 1. Now we come for the next question, solution y. Here the function numerator is a trinomial function and the denominator is a monomial. Whenever in the denominator there is a monomial, we can split the functions here terms 3x cube by 2x, 4x square by 2x plus 5 upon 2x, which can be written as y equals to 3 by 2 x square plus 2x plus 5 by 2 x to the power minus 1. Now we can differentiate each term with respect to x. So we get dy by dx is equals to 3 by 2 d by dx of x square plus 2 into d by dx of x plus 5 by 2 d by dx of x to the power minus 1. So 3 by 2, 2x to the power 2 minus 1 plus d by dx of x is 1 plus 5 by 2 minus 1 x to the power minus 1 minus 1 and x to the power n minus 1. So it becomes 2 and 2 cancels, 3x plus 2 minus 5 by 2 x to the power minus 2. So that is our differentiation of the given function. Now question number 4. If y equal to root x plus 1 by root x, then prove that 2x dy by dx plus y minus 2 root x is equals to 0. So y is equals to root x plus 1 by root x. This is our equation number 1. When we differentiate with respect to x, dy by dx is equals to d by dx of x to the power 1 by 2 plus d by dx of x to the power, it will become minus 1 by 2. When we differentiate d by dx of x to the power 1 by 2, it will become d by dx 1 by 2 x to the power 1 by 2 minus 1, and this minus 1 by 2 x to the power minus 1 by 2 minus 1. As d by dx of x to the power n is nx to the power n minus 1. Now dy by dx will be equals to 1 upon 2 x to the power minus 1 by 2 minus 1 by 2 x to the power minus 3 by 2. So dy by dx will be equals to 1 by 2 root x minus 1 by 2 x root x. ये डिनोमिनेटर में आके x टू द पावर 3 by 2 हो जाएगा और x टू पावर 3 by 2 को हम लिख सकते हैं x root x. Now we can multiply all the terms with 2x as in our proof coefficient of dy by dx is 2x. Now I am going to multiply every term with this 2x dy by dx. जब 2x से मल्टीप्लाई करेंगे 2x अपॉन 2 रूट एक्स माइनस 2x अपॉन 2x रूट एक्स, सो 2x कैंसल, 2 and 2 कैंसल, और यहाँ नेक्स्ट स्टेप में बच जाएगा x अपॉन रूट एक्स माइनस 1 by रूट एक्स. Now we know that from here what will be the value of 1 by root x from this equation. The value of 1 by root x will be y minus root x. So this value I am now going to substitute x minus y minus root x. ये हो जाएगा रूट एक्स 1 by root x की वैल्यू यहाँ से निकालेंगे y minus root x I am going to substitute. So now 2x dy by dx will be equals to x minus y plus root x, which becomes 2 root x minus y. So therefore at last when we transpose we get 2x dy by dx plus y transpose towards the left. This we transpose towards the left also, root x plus root x 2 root x. So 2x dy by dx plus y minus 2 root x equals to 0, and that is our proof. Now the next question is, if y equals to e to the power log cos x, find dy by dx. So solution, y equals to e to the power log cos x. As we know that e to the power log x studied in class 11 will be equal to x. E to the power log x is equal to x. So e to the power log x के स्थान पे क्या है, cos x है, तो ये हो जाएगा डायरेक्ट cos x function. So differentiating now this function with respect to x. This step you have to write down before differentiation everywhere. So dy by dx is equals to d by dx of cos x, which is given as minus sin x. Now the next question number 6, solution, y is equals to e to the power minus log x, and e to the power minus log x I have given the formula in class 11. It is 1 by x. So y will become here 1 by x. Now differentiating with respect to x. Differentiating with respect to x, we have dy by dx is equals to d by dx of 1 by x, which becomes d by dx of x to the power minus 1 x to the power minus 1 minus 1 upon x square will be our answer. Next question number 7. Here it is given that y is equals to 2 tan x plus sec x minus 3 cot x. So differentiating with respect to x, we have dy by dx is equals to 2 into d by dx of tan x plus d by dx of sec x minus 3 into d by dx of cot x. So d by dx of tan x will give us sec square x, and d by dx of sec x is as sec x tan x होता है, and d by dx of cot x is minus cosec square x. So minus 3 और ब्रैकेट में लिखेंगे इसका डिफरेंशिएशन minus cosec square x. So it becomes final answer 2 sec square x plus sec x tan x plus 3 cosec square x. Now the next one, if y equals to e to the power x, so y equals to e to the power x 3 cos x plus log x square. So differentiating with respect to x, we have dy by dx is equals to d by dx of e to the power x plus 3 into d by dx of cos x plus d by dx of log of x square, which in turn differentiation of the exponential function is e to the power x, differentiation of cos x is minus sin x, and d by dx of log x square. Log x, log n to the power n is n log n. So here this power 2 can be written as the coefficient of this differentiation. 2 log x, as we know that log n to the power n is equals to n log n. So now e to the power x minus 3 sin x plus 2 d by dx of log x 1 by x. So that is our final answer of it. Now the next question is product of two functions differentiation. First function sin x, second function log x. On the other hand, you can assume any function as the first function or the second function in the product of the two functions differentiation. Differentiating y with respect to x, as the formula is dy by dx is equals to first function sin x into differentiation of the second function plus sine. Now the second function into differentiation of first function. So in the differentiation of the product of two functions, first we can get first function differentiation of second function plus second function differentiation of the first function. So sin x, this will become 1 by x plus log x into cos x. Don't cancel out this x and this x. This will become in the next step sin x divided by whole divided by x and log x into cos x. That will be our answer. Now the differentiation of the quotient of a function, division. So differentiating with respect to x. This numerator is our first function and denominator is our second function. So dy by dx is equals to f2x, denominator function's square. It means that sin x the whole square. First I have write down here second function into differentiation of the first function and minus first function into differentiation of the second function sin x, which gives us d by dx of e to the power x will be e to the power x into sin x minus e to the power x d by dx of sin x is cos x upon sin square x. In the next step, if you want to take common, e to the power x can be taken as common. Left out with sin x minus cos x upon sin square x. Now the question number 11. If y equals to x upon x plus 4, then prove that x into dy by dx equals to y into 1 minus 1. Let us see this one. Solution. Y is given to us x upon x plus 4. Here x is our first function and x plus 4 is our second function. So we are going to apply the rule for the differentiation of the quotient of a function. So dy by dx will be equals to, denominator function is x plus 4, take the square of it, second function into differentiation of first function minus x into differentiation of the denominator function. Next, now x plus 4 the whole square, d by dx of x is 1 minus x, d by dx of x will become 1 and d by dx of 4 will become constant 0. Now we get it as x plus 4 minus x upon x plus 4 the whole square. don't cut this plus x and minus x. What we are going to proceed here, dy by dx equals to x plus 4 divided by x plus 4 the whole square कर देते हैं और इसको अलग कर देते हैं, x upon x plus 4 the whole square. So this x plus 4 and one of the x plus 4 will be cancelled out. Now here it is x into dy by dx. Now I am going to multiply all the three terms with x dy by dx. Here x upon x plus 4 और यहाँ हो जाएगा x into x x square. Numerator is also in a square term, denominator is also in a square term. So I can write down as x upon x plus 4 the whole square, which in turn here x upon x plus 4, this function x upon x plus 4 is equals to 1. So I can write down as this value, I can write down as y, and this value I can write down as y square. It becomes y minus y square, and the very next step, x into dy by dx, I can take common from both the term y, so 1 minus y. So x into dy by dx equals to y into 1 minus 1. That is our proof. Now next comes differentiation of the function y equals to x cos x upon log x. What is the difference here? Here the difference is that the numerator is the product of two functions as well as there is given the denominator also. So here we will apply the denominator, the quotient of the function's differentiation as well as the product function differentiation. Let us see dy by dx log x the whole square log x into d by dx of x cos x minus x cos x into d by dx of log x. So log x, here you can now see that we come here across d by dx of product of two functions. We can take x as first function and cos x as second function. So now here we will apply first function into d by dx of cos x plus cos x, second function into d by dx of first function minus x cos x upon d by dx of log x is 1 by x. Divided by this becomes denominator log square x. This x and x will cancel out. Now log x, x sin x, as d by dx of cos x is minus sin x, so it will become minus x sin x plus cos x, d by dx of x is 1 minus cos x divided by log square x. We can't cancel this log x and log square x as there is a function minus cos x also. If you want to open the bracket, you can open it, minus x sin x log x plus cos x into log x minus cos x divided by log square x. So that is our answer. So be careful. Here we have applied the formula for the division of the differentiation of the two functions, and in this formula we are getting the one of the function differentiation as the product of two functions. So here we have to apply log x into d by dx of cos x plus cos x into d by dx of x. First function into differentiation of second function plus second function into differentiation of first function. So two formulas are applicable in the differentiation of this function, that is division wala bhi or product wala bhi. Now the next topic is differential coefficient of function. Now till now this time we are differentiating only single function. Now the differential coefficient of function. If y equals to function of z, where z is a function of x, then by eliminating this z we get y equals to f. In place of z we are going to substitute this function x is called a function of function. Example, sin x cube e to the power sin x cos 2x tan ax plus b. So these all functions are the functions of functions. Now solution. Let we take y equal to sine of x square plus 5. We can't do algebraic multiplication sine x square plus sine 5. We can't open the bracket. This sine is one function and x square plus 5 is another one. So let us take that we assume x square plus 5 is equal to some other function as a t. We can store in some other variable as a t. So what happens? Y equal to this becomes sine t. Now we are going to differentiate with respect to x. So dy by dx will be equals to d by dx of sine t. But be careful, when we are differentiating the function with respect to x, the function must also be in a variable x only, not in any other variable. यहाँ पे t है, यहाँ पे x है, तो ये डिफरेंशिएट नहीं होगा. हम क्या करेंगे? इसको चेंज नहीं करेंगे, इसको चेंज कर देते हैं. So I can write it as d by dt. Whatever the variable you are taking, u or v, you can write d by du, d by dv. So it becomes now d by dt of sin t. लेकिन इसका वैल्यू चेंज नहीं होना चाहिए. dt से यहाँ डिवाइड हुआ तो यहाँ अपन dt से मल्टीप्लाई भी कर दिए ताकि ये dt और dt कैंसिल हो जाए और ये dx बचा हुआ है. इस dx को मैंने यहाँ लिख दिया. सो ये dt कैंसिल हो जाएगा. वापस हम उसी अवस्था में आ जाएंगे d by dx of sin x, sin t, sorry. So d by dt. Now with respect to t we are going to differentiate this sin t. So d by dt of sin t, now the variables becomes the same. Now it can be differentiated d by dt of sin t cos t and d by dx of, now t, what's the value of t is our x square plus 5. Now here I am going to write down only x square plus 5. So cos t d by dx of x square 2x d by dx of constant 0. Now 2x cos t. What is t? X square plus 5. At last in the final answer, in place of t, whatever the function you are assumed it, you just write down. The final answer हो गया 2x cos x square plus 5. Now comes the next one. It is also a functional function. Let y equals to sine log x. So here I am going to take let log x is equals to t. So it becomes now y equals to sine t. Now I am going to differentiate with respect to x. dy by dx is equals to d by dx of sine t. Now I have to make the variable same with respect to t. I have to differentiate. So d by dt of sine t, and here I have written down dt by dx. So d by dt of sine t cos t into d by dx of t is our log x. So cos t and d by dx of log x is 1 by x. Cos value of t is log x. In place of here t, I have to write down log x upon x, and this is our final answer. Now next comes differentiate sine x degree. Solution. This is very important question. Let y is equals to sine x degree. Since all the trigonometrical ratios are in radian form and 1 degree I have to convert in the radian by multiplying with pi by 180. It will convert it into a radian form. So what we will do it, y is equals to sine pi by 180x. ये आपका radian में change हो गया. Now this becomes the function of function. I can't take it out pi by 180 here and differentiate sin x. Okay, so what I have to do? Let pi x upon 180 will be equals to t. We assume y equal to sin t. Now differentiating with respect to x, dy by dx is equals to d by dx of sine t. Now again I have to convert this function with respect to t. So d by dt of sine t into dt by dx. So d by dt of sine t will become cos t and d by dx of pi by 180 into x this. So cos t pi by 180 can be taken out as it is a constant value, and d by dx of x, and d by dx of x is our value is 1, pi by 180 into 1. So at last our final answer will be dy by dx is equals to pi by 180 and cos t, and t is our pi x upon 180. So this I have to write down here, pi x by 180. So this is our final answer. dy by dx of sine x degree is equals to pi by 180 cos pi x by 180. Now the next question, it is very important one. Y equals to log sec x to the base a. So this y is equals to log sec x to the base e into log e to the base a. When we multiply with this log e to the base a, it becomes log e, and then only we can differentiate it. Now differentiating with respect to x, this is constant. So dy by dx is equals to log e to the base a d by dx of log t to the base e. Since it is a function of function, I am going to take sec x is equals to t. So log e to the base a d by dt of log t into dt by dx, which becomes log e to the base a d by dt of log t 1 by t, and d by dx of value of t is sec x. Now this becomes log e to the base a 1 by t, t is our sec x, and d by dx of sec x tan x. So this sec x and sec x cancels. So the final answer tan x upon log e to the base a into tan x will be our differentiation. Now next, y equals to cos x square. Since here solution y equals to cos x square, we are going to take x square as t. We'll convert into a single function. So dy by dx will be equals to d by dx of cos t, which will be written as d by dt of cos t into dt by dx. Now d by dt of cos t minus sin t into d by dx of value of t is x square minus of sin x square value of t, and d by dx of x square is 2x. So this is our final differentiation of y equals to cos x square. Now let's move to the next one. Here solution y equals to function is given cos x. Here we will assume let cos x is equals to t. So y will become equals to root t. Now we are going to differentiate with respect to x this function. Dy by dx is equals to d by dx of root t. Now again I have to convert it, d by dt t to the power 1 by 2 into dt by dx, and d by dx of root x is 1 by 2 root x. So I am going to write down now directly, d by dt of t to power 1 by 2 will be 1 by 2 root t, and d by dx of cos x, and d by dx of 1 by 2 root t, value of t is cos x, and d by dx of cos x is minus tan x. So our final answer is minus sin x upon 2 under root cos x. That is our final answer for the differentiation of y equals to root cos x. Now here comes y equals to e to the power 2x sin 3x. Till now we are differentiating only the single functions of function of a function. Now here both the functions are in the product form and both the functions are functions of functions. So differentiating with respect to x, differentiating with respect to x, dy by dx, first function e to the power 3x, d by dx sin 3x plus sin 3x second function into d by dx of e to the power 3x first function. Now here what we have to do, we have to solve it direct now. So e to the power 3x will be as such, 3x को यहाँ पे t लेंगे तो क्या हो जाएगा d by dx of sin t, मतलब d by dt of sin t क्या हो जाएगा cos t, और t क्या है हमने क्या लिया था 3x, तो ये बन जाएगा cos 3x. लेकिन अभी dt by dx बचा हुआ है, so dt by dx के लिए d by dx of t क्या लिए थे 3x, so d by dx of 3x will be 3 as d by dx of x is 1 plus sin 3x. अब d by dx of e to the power 3x के लिए अब इस फंक्शन के मैं 3x को यहाँ पे t एज्यूम करता हूँ, तो d by dt of e to the power t will be e to the power t only and t I have taken 3x here. For dt by dx करने के लिए मुझे d by dx of 3x डालना पड़ेगा, so d by dx of 3x will be 3 as d by dx of x is 1. So this becomes 3 e to the power 3x into cos 3x plus 3 e to the power 3x into sin 3x. So if I want to take common, I can take common part 3 e to the power 3x, 3 e to the power 3x common and bracket cos 3x plus sin 3x. This will be our differentiation of y e to the power 2x into sin 3x. Once again I will explain you. यहाँ पे जो product of two functions है, दोनों functions functions of functions हैं. So first we will apply the differentiation of product of function. First function into differentiation of second function plus second function into differentiation of first function. So e to the power 3x as it is रहेगा. Differentiation of sin 3x. यहाँ 3x को अपन क्या ले लेंगे t ले लेंगे. तो d by dx of sin t बना, तो d by dx of sin t it will be converted as d by dt of sin t. So d by dt of sin t क्या हुआ cos t, लेकिन t क्या ले थे 3x, so it becomes cos 3x. Now the differentiation of we have to do dt by dx also. So d by dx of t is our 3x, so d by dx of 3x will become 3 will be taken out, d by dx of x will be 1, 3 into 1 3. ये इसका differentiation हुआ. Cos 3x into 3 is the differentiation of d by dx of sin 3x. Now comes d by dx of e to the power 3x. It is also a function of function. So 3x को t लेंगे तो d by dx of e to the power t बन जाएगा, जो convert करेंगे d by dt of e to the power t will become again e to the power t, but t is I have taken e to the power 3x. So it will become e to the power 3x. Now for dt by dx, d by dx of t value is 3x, so d by dx of 3x will be 3. So the differentiation of d by dx of e to the power 3x is e to the power 3x into 3. Just now we do the multiplication and take common, that will be our final answer.